वेलकम टू कोलकाता साइंस एकेडमी। NBHM PhD का एक प्रॉब्लम, क्वेश्चन नंबर 18 कॉम्प्लेक्स एनालिसिस का ये प्रॉब्लम है। इसको हम सॉल्व करेंगे। सॉल्व करने के पहले एक थ्योरी भी हम डिस्कस करेंगे, वो थ्योरी का प्रूफ भी करेंगे और ये क्वेश्चन का सॉल्यूशन भी करेंगे। और थ्योरम का सपोर्टिव एक एग्जांपल भी हम लोग डिस्कस करेंगे। तो आज बढ़िया एक थ्योरम है, सो देखते रहिए। देखो, तो क्वेश्चन है, पहले हम क्वेश्चन को समझ लेते हैं, उसके बाद थ्योरी करेंगे, एग्जांपल करेंगे, फिर ये क्वेश्चन का सॉल्यूशन करेंगे। तो क्वेश्चन को हम ऐसे समझते हैं, एक सर्कल है, सर्कल के एवरी पॉइंट z को हम ट्रांसफॉर्म कर रहे हैं साइन z के थ्रू। तो साइन z करके एक नया क्लोज्ड कर्व मिलेगा। लेट्स से दिस इज d डैश एंड दिस इज d। सो हमको क्या करना है, ये d डैश का एरिया कैलकुलेट करना है। इसको एरिया ऑफ d को डिवाइड करेंगे, फिर जो आएगा उसका लिमिट लेंगे एज r टेंस टू 0। r है इस d का रेडियस। तो ये है हमारा क्वेश्चन, इसको हम सॉल्व करेंगे। इसके लिए हमको क्या चाहिए, इसके लिए हमको चाहिए जो एरिया ऑफ d डैश है उसको हम एक कैलकुलेट करने के, एरिया कैलकुलेट करने का एक थ्योरी चाहिए, जो कि जनरली बुक में नहीं होता है। तो इसीलिए हम ये थ्योरी अलग से करेंगे। तो पहले हम थ्योरी को समझेंगे, फिर उसका एग्जाम्पल एक करेंगे, बाद में क्वेश्चन का सॉल्यूशन करेंगे। तो पहले हम देखेंगे कि एरिया कैसे कैलकुलेट करता है यूजिंग कॉम्प्लेक्स इंटीग्रेशन। सो लेट मी राइट एरिया ऑफ closed region by a closed curve using complex integration. ओके, तो पहले हम एक थ्योरी लिख देते हैं, बाद में वो प्रूफ करेंगे। So the theorem goes like this. So area of D कोई भी क्लोज्ड कर्व हो, इसका एरिया हम ऐसे लिख सकते हैं 1/2i line integral over this closed curve, whatever be the curve, z bar dz। ठीक है। एंड अगर एक कर्व का इक्वेशन है हमारे पास, तो हम z बार को एज ए फंक्शन ऑफ z लिख सकते हैं। इफ आई राइट दिस एज ए फंक्शन ऑफ z, देन यूजिंग कॉम्प्लेक्स कॉची इंटीग्रल फॉर्मूला और रेसिड्यू थ्योरम हम इस इंटीग्रेशन को एवेल्युएट कर सकते हैं। ठीक है। तो अभी हम लोग देखते हैं कि इस थ्योरम का प्रूफ कैसे होता है। तो प्रूफ ऑफ दिस थ्योरम, प्रूफ करने के लिए हमको जो चाहिए वो है ग्रीन्स थ्योरम फॉर प्लेन कर्व। ठीक है। दिस ग्रीन्स थ्योरम is also useful for several variable calculus. So अलग से वो एक अलग importance का क्वेश्चन है। So suppose the curve is like this. Let's say this is C and the area is the D. ठीक है। So ग्रीन्स थ्योरम क्या होता है, पहले हम ग्रीन्स थ्योरम को जानेंगे, फिर उसको यूज करेंगे एरिया कैलकुलेट करने के लिए। सो ग्रीन्स थ्योरम इज द लाइन इंटीग्रल ओवर ए कर्व m dx n dy। इसको हम सरफेस इंटीग्रल और एरिया इंटीग्रल में कन्वर्ट कर सकते हैं, जो कि हमारा डेल एन डेल एक्स माइनस जो एन डी वाई है, डी वाई का कोफिशिएंट n है, उसका हम x डेरिवेटिव करेंगे, देन डेल एम डेल वाई इंटू dx dy. So this is the Green's theorem. Now using this Green's theorem, we have to calculate the area. So what do we know about the area? Area of D is nothing but this double integration dx dy, correct? That means there is a multiplier 1. Now to use this theorem, हमको क्या करना है? हमको this m and n ऐसे चूज करना है जो कि del n del x माइनस del m del y का वैल्यू 1 आ जाए. सो del n del x माइनस del m del y, इसको हम 1 लिखेंगे. तो इसको अगर 1 लिखना है तो हमको m and n क्या चूज करना है? देयर आर लॉट ऑफ ऑप्शंस, बट देयर आर वी यूज ओनली थ्री ऑफ देम. सो हम कर सकते हैं, इसको अगर हम 1 करेंगे, इसको 0 करेंगे तो भी 1 आ जाएगा. इसको अगर हम 0 करेंगे और इसको अगर -1 करेंगे तो देखो 0 माइनस ऑफ -1 दैट मीन्स 1 आ जाएगा. इसको अगर हम हाफ करेंगे, इसको -हाफ करेंगे तो भी हमारा 1 आ जाएगा. तो फॉर दिस complex theorem we have to use the third one. This third one we have to use. So third one के so del n del x अगर हाफ लिखेंगे तो n का क्या लिखना है? So देखो del n del x, that means something is differentiated with respect to x and we are getting half. So this implies n must be x by 2 plus a function of y. So we ignore that function. So x by 2 is enough to get del n del x half. Similarly m को m आ जाएगा माइनस वाई बाई 2. सो मेरा फॉर्मूला आ जाएगा एरिया का. सो एरिया ऑफ डी आई कैन गेट इट एज ओवर दिस सी. सो m आ गया मेरा माइनस वाई बाई 2. सो m dx दैट मीन्स माइनस वाई बाई 2 दैट मीन्स प्लस हाफ x dy. सो इसको हम अगर हाफ को कॉमन लेंगे x dy minus y dx. So this is the formula. So this formula is also useful for calculating plane curve using line integral. So area of a plane curve can be calculated using line integral. So remember this formula. So इसको अगर हम पहला वाला चूज करेंगे n इक्वल्स टू 1, del n del x इक्वल्स टू 1 एंड del m del y इक्वल्स टू 0, तो ये फॉर्मूला आ जाएगा हमारा x dy विच इज सेम एज माइनस y dx. तो कोई भी हम लिख सकते हैं. देखो नाउ फॉर द प्रूफ ऑफ द कॉम्प्लेक्स वैल्यूड थ्योरम, now coming back to the proof of the theorem so let us consider 1 over 2i z over dz, right? Over this this integration is overall over the curve. Now let me write z equals to x plus iy. So z bar is x minus iy and dz is dx plus I dy. So if I put all these 1 over 2i, see z bar is x minus iy and this is dx plus I dy. ठीक है, तो इसको अगर मल्टीप्लाई करेंगे तो आ जाएगा x dx. Now this would be y dy. Now I into x dy plus I into x dy minus y dx. ठीक है, so this part is what we get. Now separate real part and imaginary part. So क्या आ जाएगा? आ जाएगा this is half into x dy plus y d minus y dx. This is the real part, and the I part if I take the I part, that would be minus C. If I take 1 by I is equals to minus I, so this is minus I by 2 x dx plus y dy. Now note that this is d of x square plus y square by 2, this part, right? And therefore as C is a closed curve, therefore this integration will be 0. So this part is basically 0. So what we have is this part only. And by the Green's theorem, we already know that this is nothing but the area of the D. So remember, area of D is 1 by 2I z bar dz. So this is the formula that we have to use. So we have already proved the formula, and okay, so first part is complete. Now we come to one example which we know already beforehand, the what should be the area. So now coming to an example. Okay, we already know there is a circle with the center at the origin, radius let's say a, and the area we already know, that is pi a square is the area. So let us evaluate the area using our formula. So 1 over 2I over this C, let's say this is C, z bar dz. Now what is the equation of the curve? That is, as this is a circle centered at the origin, so I have mod z square is equals to a square. That implies z mod z square is z into z bar. So z bar is a square by z. So let us write this z a square by z. Okay. Now to use the Cauchy integral formula, or say residue theorem, we need 2 pi I. Therefore I multiplied by 2, a square by z. So a square by z. So now a square is a analytic function. So using Cauchy integral formula, this is the value of the a square at the point 0, which is a square only. Therefore it is pi of a square. You can use residue theorem also. So residue of 1 by z is basically 1. So we have shown one example also. Now coming to the question. Okay. So now let us focus. So this is the circle whose center at pi by 4. That means this is the initial line, and the radius is r square r. This is the r. Let's say this point is z, and this goes to some curve. Let's say c dash. This is c. This is d. This is d dash. So the area of d dash, I can write on 1 over 2I over this c dash. Now let's say z goes to w. So sin z equals to w. So this I can write w bar z dw. Correct, na? So now w is sin z. W is sin z. Therefore dw is cos z dz. Cos z dz. So I can write it Now if I replace w by sine z, now c dash will replace by c. C dash will be replaced by c. So it is nothing but sine z bar, and this is cos z dz. So now we came back to D, or the circle, and to evaluate this integration. So evaluating this integration, I get the area of D dash. Now note that sine z. What is sine z? Sine z is z minus z cube by 3 factorial dot dot. So if I take the bar on both sides, the sine of z bar is nothing but z bar minus z bar cube divided 3 factorial dot dot. So this is basically sine of z bar. This is just, so I can write it as sine of z bar cos of z dz. Now to evaluate this integration, we need to convert z bar as a function of z using the equation of the circle. Now coming back to the equation of the circle, as the center is at pi by 4, the equation of the circle is z minus pi by 4 mod square is basically r square. So from here I can write z minus pi by 4, z bar minus pi by 4 is r square. So z minus pi by 4 is r square by z minus pi by 4. Therefore z bar is equals to pi by 4 plus r square by z minus pi by 4. So this calculation will enable us to find the integration. Now see, we have to use calculate this integration. Now actually we have to calculate the limit r tends to 0 area of d dash divided by area of d. So this is nothing but limit r tends to 0. The area of d dash is 1 over 2i. So let me write 1 over 2i integration over this c sine of z bar. So z bar is nothing but pi by 4 plus r square divided by z minus pi by 4 into cos z dz. Okay, and divided by a of d, sorry, this is d, a of d is pi r square, correct? Now note that if I put r equals to 0, this part will become sine of pi by 4, which is a constant, and this is cos z dz. Now cos z is a analytic function all over the C. Therefore and this is C is a closed curve, so that integration will be 0. And pi r square, if I put r equals to 0, this is also 0. So this is a 0 by 0 form. So 0 by 0 form for r equals to 0. Therefore we have to, let me change the color. So we have to use L'Hospital's rule. So L'Hospital rule we have to use. Therefore we have to differentiate with respect to r. So I can write this as limit r tends to 0. Now let's say pi goes to here. Let me write 1 by 2 pi I, and this integration. Now with this we have to differentiate with respect to r, not z. So this becomes So sine of something, so that becomes cos of pi by 4 plus r square by z minus pi by 4. Now integration with respect to r, so this becomes 2r by z minus pi by 4. Now cos z is constant with respect to r, so this is, and pi already taken care of, so r square differentiate, you get 2r. Now this, now 2r, you see 2r is independent of z, so it can be taken out here and we can cancel with this 2r. So basically this limit is r tends to 0, 1 over 2 pi I over this circle cos pi by 4 plus r square z minus pi by 4 cos z dz over z minus 2 by pi by 4. Now there is no r in the denominator, so I can easily replace r equals to 0 here. Therefore the limit becomes 1 over 2 pi I. Now if I put r equals to 0, this becomes 0, so it is cos pi by 4, so therefore this is cos pi by 4 into cos z divided by z minus pi by 4 dz. Now using Cauchy integral formula, so Cauchy integral formula will give us this is the, so this is f of pi by 4. So if I call it f, then this is f of pi by 4. So this is cos pi by 4 into cos of pi by 4. So both is cos, so that means 1 by root 2 into 1 by root 2, which is half. So this is our answer. Okay, so this completes the solution of the question. Hope you like the video, you learned some new thing, and please subscribe our channel if you like the video, and we will bring many questions from NBHM CSR net, IIT JAM. So stay tuned for more videos. Please like and subscribe. Thank you very much.